and a very good evening to you all. On behalf of MIST Aeronautics and Astronautics Club, I am Ashmita Sharkar.
And I am Shikdar Maggie.
We welcome you all to our most awaited and prestigious event called Tales of a Luminary. So, our today's position of the keynote speaker is prestigiously and most rightfully ornamented by the most humble human being, an illuminary star in the field of astronautics, and the most honorable person, none other than Dr. Gautam Chattopadhyay sir. So, Sir is a senior scientist at the NASA's Jet Propulsion Laboratory, California Institute of Technology, a visiting professor at the Division of Physics, Maths, and Astronomy at the California Institute of Technology, Pasadena, USA, a Bell Distinguished Visiting Chairperson at the Indian Institute of Science, Bangalore, India, and an adjunct professor at the Indian Institute of Technology, Kharagpur, India. Sir has more than 350 publications and has about more than 20 patents. And he has won numerous awards all across the world. And this is a very short description of whatever Sir has achieved throughout his lifetime till now. So undoubtedly, this is beyond our imagination that how big of a person he really is. So we all are really grateful to have you among us today, sir. I would also like to mention that we have our respected head of the department, Dean of Mechanical Engineering Faculty, and our chief patron at MIST Aeronautics and Astronautics Club, Air Commodore Abdul Salam sir. Sir is our constant support at MEC, and we are always obliged and grateful to him. So on this note, I would request sir to say a few words on the light of today's occasion.
Bismillahirrahmanirrahim. Am I audible, Asmita?
Yes, sir, you're audible.
Today's speaker of the session, Dr. Gautam Chattopadhyay, our Director of Students Welfare, then faculty members of Aeronautical Engineering Department, and my dear students. Assalamu alaikum and good evening from Dhaka. It is our privilege to have among us the senior research scientist of Jet Propulsion Lab, NASA. For any engineers around the globe, it's a matter of pride to serve in NASA. And for aeronautical engineers, it's a dream place. Today, Dr. Gautam will share his experience with us, especially the students who would like to serve in NASA and other most potential places. I express my deep appreciation to the speaker for sparing his valuable time and to be us this evening. I'd like to thank the organizers of our MIST Aeronautics and Astronautics clubs to take this extra initiative to organize this event during the pandemic. Sir, here I would like to mention that during this pandemic, all of the universities are closed, but in MIST, we are conducting the online class, and you will be glad to know that our students are spontaneously participating in the classes, and they are also participating in the examination. And in addition, they are doing this co-curricular and extracurricular activities. So thank you very much all for taking this pain. I'd like to thank Colonel Saib, our Director of Students Welfare of MIST, for his continued support to different clubs run by the students. My sincere thanks to Group Captain Mahbub and all the other faculty members of Aeronautical Engineering Department to be in this event this evening. My sincere thanks to all the participants for their spontaneous participation. I hope the program will be successful. Without further elaboration, I would like to request the host to proceed with the main attraction of today's session. May Allah bless us all. Allah Hafiz.
Thank you for the kindest of words, as always, sir. And today we also have almost all of our faculty members from the Department of Aeronautical Engineering. All of them have always been extensively motivating to all of us. Thank you for all your presences. This means a lot to all of us. Thank you for being there. So now, since we are all geared up for the session, shall we start, Maggie? What say?
Yes, sure. I think that's the best time to start. Let's not further.
Okay. So starting with Namaskar, sir. How are you?
I'm doing good. Thank you so much. I really want to thank all of you and Professor Salam and all the young students who have taken time and given me this opportunity to meet you, though virtually. Hopefully, one day we'll all meet in person. I'm sure that we are going to come out of COVID more stronger on the other side. So I hope that you all are staying safe and practicing social distancing and wearing masks whenever you are going out. So all these good things that we have to do. And I'm really happy, as I was saying, that to be amongst you, to talk to you, because students and young professionals, they are our future. And so I am so happy to see, as Professor Salam had mentioned, that you all are going through very difficult time. All of us are particularly the young students and young professionals, because you like to be amongst the friends and your colleagues. That is very important. These interactions are very important. But you are stuck at home and you are still studying, but finding this opportunity to using these platforms and connecting globally. And that's why I am very, very happy to be here and to get this, you all gave me this opportunity. Thank you very much.
Thank you, sir. As always, you're very humble and kind. So, sir, we always look forward to meeting people like you in person. So we'll be waiting for that. And sir, next, the first question that I'd like to ask you is that we all know that you come from a very small Indian village, Novogram. So from there to NASA, like literally NASA, that's like a dream place for everyone. So how was your journey to that place from there to there, and how did you get to NASA?
So very good question. As I always tell people that my journey from Novogram to NASA, because Novogram is a small village outskirts of Kolkata. And actually, when I was growing up, it's like any Bangladeshi village, that Shujalang, Shufalang kind of village. And so there are not much infrastructure. I went to a school called Novogram Vidyapit. We had few good teachers, of course, but we did not have any infrastructure. Even in the classroom, we did not have cement floor. We had mud, and so one blackboard always hanging at an angle, the way you see it in movies. And then one of the things, and I grew up in a very poor family, but I am not alone in this. I know that many of you who are actually listening in are also have similar situations. But one thing we always did is that my mother, we are actually six brothers and sisters. I have one brother and four sisters. We are six of us. I grew up in a one bedroom home, only one room. So it was difficult, and my parents struggled. Sometimes we did not have two full meal a day. And then what happens is, as a kid, if you are hungry and you cannot then fall asleep, then one thing I always tell people that it does not cost anything to dream, and dream big. So that's what I used to do when I was a young kid, cannot fall asleep in the night. And I used to think about, science, NASA. Of course, NASA is such a big organization across the globe that inspires, awe. So how they all do this? Are they all human beings? So that is the kind of impression that you have as a kid. And also, I had a little bit of fascination about another place that is written on the screen there, California Institute of Technology, because I used to read in newspaper about Richard Feynman. That's such a great professor of physics and such a small university and such a big name. So I used to about dream, that role play that we do in dreams, that I am in NASA or in at Caltech. So I used to do that. And then my parents always encouraged all six of us to do one thing, that my mother used to say that for poor people like us, only way to get out of poverty is to study hard, study well, and work hard, because there is no alternative to hard work. And we did that. We actually worked hard, and then I my brother and I, we both went to Bengal Engineering College. That is the second oldest engineering college in India. That was established in 1856. And there from, so we, of course, we had scholarship, otherwise we couldn't have gone. And then I had to, after I finished my undergraduate, I did in electronics and telecommunication engineering. I had to take up a job there because of our financial situation, because I always had inside me to do higher studies, but that was not the right time for me. So I went to a research organization in India called Tata Institute of Fundamental Research. That is actually, again, an amazing place that opened my eyes. They were building radio telescopes, giant meter wave radio telescope they were building at that time. So I played a very small role. I designed and developed the local oscillator system for such a big instrument. But there my eyes opened, because TIFR is an amazing research organization. There are very renowned professors like Professor Jayant Nalikar is a big name in astrophysics, as well as Professor Govind Swarup, who recently passed away. He started the field of radio astronomy in India. So I met those people, and then actually I started thinking, my training is not enough. I need to study more. Then I applied. I actually got opportunity to do my master's in India, in Institute of Science, Bangalore, and IIT Kharagpur. But I came to US. I came to Virginia, University of Virginia. And there, then I thought that, in my head, always had that bee in the bonnet that's about Caltech. So I told my master's advisor, that I am going to apply for my PhD to 3 places. If I get there, then I'll go. Otherwise, I'll stay back and work with you. It's kind of I don't know whether I was bold or stupid, maybe both. And then I applied, and luckily I got admission, and then I came to Caltech. The California Institute of Technology is a very small university. There are only 2,000 students, and there are 300 faculties and 600 postdocs, and it produced 41 Nobel Prizes. Of 40 people got 41 Nobel Prizes, because Linus Pauling got 2 Nobel Prizes. One in chemistry, and one is peace. If you are following the Nobel, because this is the Nobel week, all the Nobel Prizes are coming out this week. That 2 people who had graduated from Caltech, did their PhD from Caltech, got Nobel Prize this week. One is Andrea Ghez. She is the 4th woman to got physics Nobel Prize. She currently is at UCLA, but she did her PhD with Gary Nugerbauer, who used to sit next to my office when I was doing my PhD. And though I actually was doing my PhD in electrical engineering, but my advisor was in physics. So I used to sit in the physics department, and there every winter, Stephen Hawking used to come, and he used to sit only 2 doors from my office. So I used to see him. I used to talk to him. You all know that this year's Nobel Prize in Physics actually had some work in Professor Hawking's work was involved. That Sir Roger Penrose's work about black holes, singularity of black hole. Stephen Hawking also had contributed. I think that if he was alive, then he would have also been one of the Nobel laureates this time. And then to meet him, all these big name physics professors used to come. I got the opportunity to meet them all. One of them was Kip Thorne, who got Nobel Prize in Physics for detecting the gravitational waves for the first time in 2017. And then other people like, 2018, Frances Arnold, she got the first woman to get Nobel Prize in Chemistry, 2018. And this year, 2 women got Nobel Prize in Chemistry as well. So if you look at out of all the Nobel Prizes, 4 of them are women for the first time. 1 in physics, 2 in chemistry, and 1 in literature. So that is, I believe that for the first time, they're actually waking up to the reality that there are women, very credible and highly qualified women are out there. And so they deserve this honor. I'm very happy about that. So when I was finishing up my PhD, then one day I was sitting in my office trying to finish, write my thesis, and then I got a phone call from NASA saying that they want to hire me because they have read about my work, they have read about all the papers that I have written, and luckily at that time there was no video phone. Otherwise, they would have seen me. I'm jumping up and down because that is my dream, right? So I was thinking that is it that same dream that I used to dream as a kid? I'm still dreaming it now, or is reality? And then I went over there to give a talk. And when NASA or people like organization like NASA, they hire here, they do very differently. So I had to give a lecture, a talk, and then everyone was there. And then throughout the day, I went and met people, different people. They do not ask you, math question, go and solve this math problem or science problem. What they try to look at you, how you think, that you already are trained, right? When you are doing your PhD or when you are studying in at a renowned institution like where you all are, so you have already done your studies. So what we are trying to see is that what is your thinking process? Because you'll be faced challenges at your work, at your wherever you go, you'll be facing challenges, you have to solve problems. So how do you approach in solving those problems? So that is one of the key aspect. And so I met people there, and then I was offered that job. Of course, I had job offers from other industry and all, but they were paying much more. But working for NASA has been a dream come true for me, and it is not getting old at all. I have completed 21 years in this organization, but I still feel like that I'm a kid in a toy store. Every day I'm excited to go back to work. Of course, now we are working from home, but sometimes people say that when Monday morning it is raining outside, you don't feel like going to work. I never felt that way, because I'm looking forward to go back to work, meet my colleagues, and because it's exciting. We are trying to do something that is new and innovative. And so one of the best thing about NASA is we get best people from all over the world. If you actually see our group, we have people from all over the world. And that is one of the most exciting, because that diversity in thoughts, the diversity in ideas, that's how we thrive. And that's what NASA has created, this ecosystem where, and people are smart here. All the people are smarter than I am. So I always tell people that if you want to be successful, what you do is surround yourself with people who are smarter than you. And that's your key to success. So that's how I came from Novogram to NASA, and really enjoying every moment of it.
Thank you, sir. Your story actually seems like a fairy tale, and the way you depict it, I must say you are a very good storyteller as well. We absolutely love the way you contributed to it. So, moving on.
Asmita, just sorry
Yes,
for interruption.
yes,
Before we
sure, sir.
proceed to the next question, may I add up just few points
Sure,
with?
sir, surely.
Sir, thank you very much. The story that you have narrated, I am narrating this story for last 12 years to my students. Sir, you'll be happy to know that we in MIST, we started aeronautical engineering first time in Bangladesh. And since then, I am answering one common question from my students, sir, what is my future? And I'm repeatedly telling that you don't worry about your future. Please prepare yourself. And you are not a product of MIST only. You are not a product of Bangladesh. You are a global product. So if you have the knowledge, then the industry or the organization will look for you. So prepare in this way. So I think I failed to motivate my students, but your words, just few words, I think it will be more encouraging to my students. So sir, please keep on telling this thing that it's not impossible. It's not impossible, and people, organizations will find the right people, those who have. And the success story that we are listening from, sir, it doesn't come so easily. So the story behind that, the hard work, the passion, and everything. And I'm lucky that what I said, that all my students are not frustrated. Many of them are very encouraged, and I think from today they will be more encouraged. So please keep on adding this. Thank you, sir, for giving me this opportunity.
Thank you.
Thank you, sir. And Salam sir has always motivated us in the kindest and truest of ways. And he from the beginning of our department till today, he has been the founding head of the department and the most inspiring person in the field of aeronautics in Bangladesh. So thank you for that too, sir. So moving on to the session, as we know, sir, from your distinguished profile that you have had your BE from IIEST in Electrical and Telecommunications Engineering. You then had your MS from the University of Virginia, that too in Electrical Engineering. And then you received your PhD from Caltech in Electrical Engineering as well. Then after a few steps of your life, you joined NASA in 1990 and have been working, as you mentioned, very happily thereafter. So, from coming from an electrical engineering background, what really inspired you into aeronautics and NASA?
So this is a very good question. One of the things is that organization of like NASA is actually very multidisciplinary because we need people from all walks of life. So sometimes, people ask me that, okay, do I have a future? I'm doing my civil engineering. Do I have a future in NASA? I'm doing economics. Do I have a future in NASA? So we need everyone. As long as you are hardworking and you are ready to give 100%, then we are interested in you and you are willing to contribute. The reason is this: if you see, we are trying to what NASA does is actually we are trying to solve science question, big science question. One of the question that primarily we are trying to answer is, are we alone in this universe? Is there life anywhere else other than our planet Earth? This is a big question. And to answer that question, we need to develop technologies, we need to develop instruments, and we do not only need aeronautics because we'll have to go somewhere, right? In outer space, we need aeronautics, astronautics, we need mechanical engineering. I know some of you are doing mechanical engineering. We need thermal engineering, we need electrical engineering, electronics, we need physics, we need chemistry. So we have physicists. My next door office mate is a very renowned physicist working on cosmic microwave background, the first light that actually came from the Big Bang. So he's working on that. He's making fundamental contribution. Hopefully he will get Nobel Prize one day. I actually work with him. And then people that are chemists, because recently, if you are following the news, that there was a very interesting discovery made on the atmosphere of Venus. The phosphine was detected at a very high level in the atmosphere of Venus, and the way the chemistry we know in Venus atmosphere, that we do not get that amount of phosphine from abiotic sources. The question is it biotic? That means, is there some life there that is producing this amount of phosphine? So to do that, we need what? Chemists. We need to build the instrument to do the detection. That was done at very high frequency, my work area. And so those, you need people of all kinds of backgrounds. So what I am doing, and I'm actually learning every day about physics, I'm learning about chemistry, because when you build instrument, when you are thinking about the new instrument that is going to make this kind of discoveries, then you'll have to actually understand, you have to interact with physicists, you'll have to interact with chemists, you'll have to interact with mechanical engineers, thermal engineers, and all of us, we speak different languages, because you all know that engineers' language is very different than science language. And then we'll have to bridge that gap. So my role has become that if I don't understand enough physics, then I won't be able to talk to the physicist and translate that into requirements to the engineering team. So that's how we become kind of jack of all trades, unfortunately, but that's what we'll have to do. I understand very little about all these things.
Okay, sir, thank you very much, sir. So we see that NASA really requires a lot of people. So everyone has hope here. So what we want to ask you is that, sir, you're a senior scientist at NASA's Jet Propulsion Lab. So what are the current ongoing researches in NASA's Jet Propulsion Lab, the newest ones, the trends that we don't know as we don't really get the insights from there. So if you could share with us so that we can be enlightened.
Yes, actually, we are doing a lot of different things. Lot of different research is going on. NASA is a big organization. As we know that we have so many different programs. But again, as I mentioned in the beginning, that what our main aim is to do science, because you can develop the best technology in the world, but if it's not addressing some science question, at least to us, that is not very useful. So we develop technologies keeping in mind, first we ask, this is how it works. Suppose there is a big science question. The scientists want to answer, a unknown, that we want to find that what is happening. That is the first level, the science question. I'll give you an example. One example is, suppose we are trying to find out that, scientists believe that when Earth was created, there was no water on Earth. And comets brought water, Dhumketu, you all know that, so that they brought water to Earth. Then this is the big science question, that did comets bring water to Earth? Right, this is on the top level. The next question that you'll have to ask is, if I want to answer that question, science question, what kind of measurements I can do to answer this question? And then the next level is to answer, do that measurement, what kind of instrument we need to build, what kind of detectors we need to build, what kind of mission that we'll have to plan. So again, it turns out that the water I was talking about, that there are different kinds of water. Water that we drink is H216O, because that is the oxygen has different isotopes. 16th isotope is the most stable isotope, and that is most prevalent water on Earth. But there are other kinds of water, H217O, H218O, and with deuterium as well, HDO. So if you make the ratios of abundances of different kinds of water and the D over H, that is the deuterium over hydrogen ratio, it turns out that if our planet has a certain ratio that matches with some of the comets, and if the ratios match, then the source has to be the same. So that is the measurement that we can do. We can measure the abundance ratio. And next question is, to do that measurement, what kind of instrument you need to build? So that is one of the things that we are looking at, that we are building instrument to go to comets and do these measurements and find an answer to that question, that yes, water was brought to Earth by comet. This has huge implication, because when we are trying to find life on other planets, people ask me this question, that what do I believe? I mean, do I believe that there could be life somewhere else? So to be on, to set the stage clear, that we have not found life anywhere else. No form of life we have found anywhere outside our planet Earth. So whatever you read on the internet, don't believe about the alien stories and all. So we have not found life anywhere, but we are trying to find. And it turns out my answer to that question is that I think that life does exist somewhere. There is a probability of finding life somewhere else. Why do I say that? I say that because if you look in the sky, our Milky Way galaxy, Akash Ganga, we call it in Bengali, galaxy has 100 billion stars. 100 billion is 11 zeros after one. And then we have about 100 billion galaxies in this universe. So this is huge number of stars in this universe. And we are finding that most of these stars has not only one planet, multiple planets. So there are trillions, some zillions of planets out there. So what is the probability that we find one planet whose conditions are such that it can, life can exist? It has to be finite. And we are actually building those kind of instruments. We actually found more than 4,000 exoplanets, planets that is outside our solar system. And why I said that trillions of stars and trillions of planets, why did we find only 4,000? The reason is we have looked only in our galaxy, only very small areas so far, because we do not have the technology to look far and actually detect planets and very far off places. So that's why we need all of you to come and work with us so that we can build instruments for the next generation instrument to detect those and make those discoveries. And so to do that, we are actually building new instruments to find more planets, exoplanets, we call them. And we are also looking at our own solar system and seeing that can we build instruments to go and try to find out, did life exist anywhere before, or does life exist there today, like Mars? So my background picture I was telling before I started that is actually a Mars background, and in the background you can see our planet Earth, beautiful planet Earth, and one young girl is entering, astronaut, to Mars. This is very symbolic because I hope that the first astronaut on Mars will be a woman. So that will be very exciting. And we go back to Mars. Mars, we are trying to, like we all know that recently we launched in July our rover, Perseverance rover, that is on its way to Mars. It will reach there in February. And one of the main aim of that mission is to find, was Mars ever habitable? Did life existed on Mars ever? Or does it exist even today? So that is the kind of we are building instrument to actually answer that question. And it turns out that there could be possibility of life in other planetary bodies in our own solar system, like Europa. Europa is a Jupiter's moon, and there is a water ocean underneath its ice surface. So if there is an ocean there, and that means that there is a source of energy that is keeping the water in the liquid form. If there is water, if there is energy, is there life? So that is we are trying to find out. Another planetary body is a moon of Titan, moon of Saturn. It's called Enceladus. And Enceladus actually spewing water out, we found from an instrument, is spewing water out. The question is, what else is there in that water? It has water inside. Is there any organic materials? We all are Bengalis. Many of our Bengalis here, we like fish. So I'm very much interested in finding out, is there any fish out there? So these are the things that we are actually building instrument for. We are also building instrument. This is for planetary. We are trying to find out how all these things happen, how new stars are formed, how galaxies are formed, from where we all came from. So we are building instrument to actually answer this kind of fundamental questions. So there is a lot of different projects going on, science projects going on. We are planning to go back to Jupiter. We are going to Europa. We are planning to go to Enceladus. And we are planning to go to Venus maybe again, so that we can actually answer those questions. So these are the big project that is driven by science that is going on at NASA.
Thank you, sir. The space and science really sounds more interesting and intriguing in your words. So thanks for the insights. So since we are talking all NASA here, I would delightfully like to inform all of us here that sir has recently, like this October, sir has completed his 21 years of services in NASA. This is quite a big achievement, and we congratulate you all, sir. So could you please share with us about your experiences as a real insider in NASA?
Yeah, so as I said, that I'm really excited, and I'm surrounded by people in a very young team I have. That is one of the things that we always try to do is get postdoctoral fellows who are just coming out of PhDs, and so that because you all young people, you are all brave, you are bold. What happens is that many of the faculties who are listening in, they know that as one of the thing experience does to us is that we get corrupted. We get little bit, think that this is possible because through our experience, we say, oh, this is not possible. But young people, they do not think that way, because to them, impossible is not a word in their dictionary. So they think, no, we can do that. And that spirit we need, organization like NASA, we need that spirit. And that's why we always try to recruit young professionals who are coming in, so that they keep us on our toes, saying that, no, I'll prove it to you that you are wrong. And I'm very open to that. We are all very open to that, because if you come to my office, you'll find that I'm surrounded. All the people are walking in all the time. My door is always open, and we are always on the board, trying to solve. And then they say that you can do this, and I always tell them, prove it to me. Why do you think we can do this? Right? That is this exchange of ideas, and then we go somewhere, because we have to be open, to ideas, new ideas. If we shut ourselves out from ideas, then we do not progress. So that's what happened. So ever since I joined NASA, I joined as a young, just out of my PhD. So I went there. So then people who were there already experienced, big name people, they treated me exactly the same way, because they were very much open to listening to what I have to say. And that's how we actually made a lot of progress. We built a lot of instruments. We built, a lot of innovations that we created that was not possible. Now it is becoming feasible. Like I was telling you that we are building instruments to go to a comet. Before it was very difficult, because any planetary mission costs a lot of money, because if something weighs every extra kilogram of mass, you are doing astronomy and astronautics and aeronautics, that so launching any mass in space is a big challenge. So if we can make something that is low in mass, and also it draws low amount of power, then it's very attractive. But it's not easy to do that, because it has to do all the functions, but at the same time it has to be very small. It has to take hardly any power. Like per instrument, we are talking about 10 to 15 watts of power per instrument. 10 watt to 2 watts, 1 or 2 watts is your night lamp, takes 1 or 2 watts, and you are building an entire instrument with 5 watts of power. That is very challenging. But through these interactions, through these innovations, we are now through my I'm the PI on that. We are building an instrument that can go to a comet and do all those measurements, but it draws only 5 watts of power. It weighs only 2 kilograms. It used to be 30-40 kilograms and hundreds of watts of power. Now we brought it down through all these innovations. So that's what we are doing. I am also involved in for astrophysics missions. One of the things that we are trying to do, that scientists believe, Einstein has also predicted that when the universe was created, it must have created gravitational waves, and gravitational waves must have polarize the first light that came out from the universe. Is called cosmic micro background signal. And so we are trying to measure the polarization of that signal. That is very challenging, because the signal level you are talking about is so tiny that is much below the noise floor. So how do you detect that, which is much below the noise? So I have built, antennas, and we are building detectors for those kind of instruments, that will prove once that really, gravitational waves existed at the beginning of the universe. So it will prove some fundamental theories. So that's why, and also one of the things I'm also involved in earth science, that is pollution. Climate change is a big thing all across the globe. We all know that. And it turns out that the pollutants, if they travel through the upper atmosphere, called the troposphere, and we are actually building instruments to measure those and try to see how that transportation happens. If today you burn something that creates some pollution in Dhaka, Bangladesh, in a couple of days it will show up in Pasadena, California, because this is not only a digitally connected world, it is really connected world in real sense, because we are not isolated anymore. So so I'm building instruments to actually answer some of those questions as well.
Thank you, sir, for your answer. So one of the things that we have not yet mentioned about Dr. Gautam, because we wanted to keep the best for later, is his research interests, which include microwave, millimeter wave, and terahertz receiver system, and radars, and development of space instruments for the search of life beyond Earth. And Sir has already mentioned that he does believe that there is life beyond Earth. So the question that I want to ask you is, so how far do you think are we from finding actual life in beyond space? And there's another thing that I would like to add to it. That is, I've once seen a documentary. So there are a lot of documentaries related to these things, and one was that there is a planet in somewhere that is very similar to Earth. Is that really true? So I'd like to know from you.
So let me answer your second question first, is that yes, we actually found, we call those planets, we are actually looking, when we find, I said that we found 4,000 plus exoplanets. And it turns out that we look for planets, we call them in the habitable zone or Goldilocks zone. What are habitable zone? Well, first of all, we are looking for Earth-like planet that is, that has more of, not gaseous giants, right? So when we find those, we are finding that there are many planets which are in that habitable zone, which means, what do I mean by habitable zone is that temperature is such that water can exist in liquid form on the surface. See, when you are looking for life, we are looking for hydrocarbon-based life, right? And so that means the kind of life that we know. There could be other form of life, but we cannot search for it. That's why you are looking for planets which are in the habitable zone, where the temperature is such the water can exist in the liquid form. And we actually found quite a few planetary systems where we believe the temperatures are such that in the habitable zone. They are rocky planets, not gaseous giants. And we are trying to find out, do they have atmosphere? And so that you are correct that we did find quite a few planets which are like our own planet and in that habitable zone. And when are you going to see, find life somewhere else? That is difficult to predict because we'll have to keep trying, and we'll have to build new technologies, and many of the systems that we are finding, they're not very close from our planet. One of them we found 4 light years away. And 4 light years, when we say we don't realize how far they are. They're actually very, very far. It will take 40 million years to go there if we are going with current day's technology. So we cannot really go there anytime soon. So we'll have to, observe all those things from here. So again, I cannot say when you can find life, but I'm very hopeful that one day, maybe in your lifetime, you all will contribute in a way, and then you will detect the first life outside our planet Earth.
Thank you, sir. We would be praying that you find you and discover it yourself too. We would be really hoping your research goes very well. So, just as you talk so much passionately about dreams, I would like to know that what are your thoughts about the young generation of Bangladesh? And we people really dream to become like you, sir.
So not like me, you'll be becoming like yourself, and you'll be doing really good things. I am very, very hopeful, about the young generation across the globe, not only in Bangladesh, across the globe. And I know, I have never been to Bangladesh. That's my really, I'm not fortunate that I have not gone. I hope that one day I'll have to go. It is my situation, and like, Rabindranath Thakur has a very beautiful, poem that I'll say in Bengali. দেখা হয় নাই চক্ষু মেলিয়া ঘরতে শুধু 2 পা ফেলিয়া একটি ঘাসের শিশির উপর একটি শিশির বিন্দু. So I grew up in Kolkata, not too far from Bangladesh, but I did not get the opportunity to go there yet. One day, hopefully, I'll go there and meet you all. But I know I'm hopeful on the young generation, because all of you have a global mindset. You have to be open to your ideas, to your thoughts, and only then you'll be able to make progress. Because if you are clustered in your thoughts in a way that like kupamunduk, we say, frog in a well. If you do that, then we do not make progress. But what I read when I have a lot of friends in Bangladesh, a lot of people, I actually see them there. We all are highly talented. No country has ownership on talent. If you go anywhere, I have traveled to many countries around the globe. I have gone to more than 35 countries. I have been lucky to do that. And I have found that people are so smart. Young generation, they're so smart. They know so much more. So you'll have to use your smartness. You'll have to use your talent. I know sometimes infrastructures are not there. There are a lot of barriers to overcome. But because of your spirit and because of your hard work, I think you all will be able to do that. And one thing I suggest to you all is to talk to your friends. Make friends, talk to people who maybe not working in your area. Maybe they're not studying your field. Maybe they're studying completely different things. But talk to them, because this teamwork, this interaction, human interaction is the most important thing. We talk about AI, we talk about robots, we talk about all those stuff. But personally, I believe that innovation happens through human interactions. Because when we are talking to other people, when we are interacting with others, exchanging ideas, and that's how we come up with new things, new ideas. So I know currently you cannot do that. You cannot go and meet people and drink a cup of tea or coffee and discuss. But again, we'll be out of these, and then go there, take a cup of tea or coffee, whatever your favorite drinks, and sit with your friends and discuss everything. Be open, and then you will find that new ideas will come up. When you are discussing your problem, we always say that, right? If you have a problem to solve, if you keep it to yourself, you are not able to solve that. If you are discussing about it, then you will get ideas. People will give you ideas, different perspective. So and again, I am extremely hopeful that you all are going to do great. So that is that. I am eternally optimist person. You can see most probably in my demeanor. I'm always excited, and also I'm very optimistic person. And I think that yes, short term, everywhere there are challenges. Sometimes you can see the negative aspects of everywhere. But my thing is that negative things are there, but it should not pull you down. You have to be hopeful, and hope is one thing that actually takes us forward. I won't be here today. Whatever small things that I have achieved, I don't think I have achieved a lot, but whatever small things I've achieved, it happened because I worked hard, but I was hopeful. Your outlook to life is very, very important.
Thank you, sir, for such beautiful words and advices. I'm really hopeful that we don't disappoint you in this aspect. So, moving on, we are almost at the end, and Maggie will shoot the last question. Before that, I would ask the audiences to pull up any question they have to sir. This is your chance, guys, so don't waste it. Write up any question you have in the chat box. Please be relevant and as specific as possible, and we will be taking the top 5 best questions to be answered by sir himself. So, Maggie, you can proceed.
Thank you, Ashmita. So before we move to our question answer section, there's one last question for you. So, sir, we'd like you to go back to your childhood for a moment and share with us one of your favorite memories from there.
So yes, childhood, I have a lot of memories, of course. As I said, my best memories are with my brother. My brother and I, we are only 1 year apart, but he's my best friend, has always been. He's a mining engineer himself. And the story that actually has really stayed with me. And also I want to say a little bit about my family, that I have one daughter, and my wife is a scientist herself. She is an environmental scientist. She did her PhD from University of California. After we got married, actually she was expecting our baby when she was defending her PhD thesis. So and she has been a big support, because if you do not have, you have to support each other. Nowadays, you want to talk, because all of you, you at one day you will find a life partner and move on. in your life, it's very important that all of us help each other, because it is not that women only take care of everything. That attitude is not acceptable in today's world, because women are professionals. You all are professionals, so you have your work, and so home and work, that balance, all of us will have to do. I try to help my wife. I cook, I clean, I do everything, because she does that too as well. So not that I'm doing anything out of the world. So going back to my childhood memories, I remember one thing, that my mother, actually my mother is my if there's someone says that who inspired you most, that my parents, my mother actually inspired us a lot. She again, they were all, my family actually originally from Bangladesh. They are from Borishal. Borishal, my father's side are from a village called Batra, and my mother's side is Kholishakota. Actually, sometime I go to the Google map, I try to see those places on the map. Kholishakota I could find. And so they are from that. They were born, those places. But again, 1947, during the partition, they came to as a refugee. They came to the Indian side, and so my mother did not have a high formal education. She studied only up to 8th grade, and she had lost her father at a very young age, 1.5 years old she was, and so struggled a lot. But she had, I don't know, the wisdom and the courage that she has is amazing. And she used to tell us one thing, that you all, whatever you do, you will be studying, you will be becoming
There is an internet problem for Sar's side. Let us wait for him a little. I'm sure he'll be back soon.
Okay.
So in the meantime, anyone that has questions, please write it down so we can read it out and select the best ones, and so that we can read it out to Sir as soon as he comes here. And let's wait for him. Yes, someone raise your hand. Is there something you want to let us know? Please tell us in the chat box if there's anything you want to know. In the meantime, I'd ask everyone from Mac to please go through the questions so that you can select them from us and let us know. It would be easier for me and Ashmita to pick them. Sir is trying to join again. There might be some technical issues. We are very sorry to let you know that Sir is trying. Sir has tried multiple times and yet could not connect to us. And so he told us to convey his apologies to everyone. And thank you everyone who has been here for all this time. I would like to thank Salam sir and every other faculty member, all the attendees, and everyone who placed questions. We are sorry that we could not take it. There must have been some technological problems. Inshallah, if we get sometime again, if we can manage, we'll try to bring sir again. So for today, we have to end it here. We're sorry again. Thank you everyone for joining us.
Thank you for joining with us. Goodbye. Thank you.